Hi guys, this is O-Level Chemistry, paper 11, June 2019, question 21. Why is ethanoic acid described as a weak acid? It is an organic acid? No, weak acids can be inorganic acid as well, like CO2. When it dissolves in water, it forms a very weak acid, which has a formula of H2CO3, and this is known as carbonic acid. So organic acids are not the only weak acids that are there. It is a poor conductor of electricity. No, as a liquid, it will not conduct electricity at all. It will only conduct electricity in the aqueous state. It is only slightly dissociated in water. This is the definition of a weak acid. A weak acid is only partially dissociated in aqueous solution. It reacts only with very reactive metals. It is not necessary that it would react with very reactive metals. It would react with metals that are more reactive than hydrogen. So even with less reactive metals, it would eventually react, but the rate of reaction would be slower. So this makes option C the correct option for this question. Question 22. What is the best method to prepare a pure sample of copper 2 sulfate? So now we have a salt that is soluble in water. So the method of preparation would be with an insoluble salt dissolving in an acid. That would be the method of preparing a soluble salt. So add copper to aqueous zinc sulfate. Copper is less reactive than zinc. It will not displace zinc. Add copper to dilute sulfuric acid. Copper is less reactive than hydrogen. It will not react with dilute sulfuric acid. Add copper to carbonate to aqueous sodium sulfate. Copper to carbonate is not soluble. No, it is copper to carbonate, copper carbonate. But here we are having a displacement reaction taking place. Copper to carbonate added to aqueous sodium sulfate. No, double displacement reaction will not take place here. So this option is incorrect as well. Plus, we needed an insoluble salt reacting with an acid. So we have copper to carbonate reacting with sodium sulfate. Both of them are salts. One of them is not an acid. So this is also another reason why this reaction will not occur. And it's not the method of preparing a pure sample of copper to sulfate. Add copper to oxide. This is an insoluble copper salt and it reacts with sulfuric acid, which is an acid. So insoluble salt plus acid gives us a soluble salt, and the soluble salt in this case is copper 2 sulfate. So this method is correct. Therefore, option D is the correct option for this question. Question 23. What is the percentage by mass of nitrogen in ammonium nitrate? So we've got two atoms of nitrogen in NH4 NO3. So that would be 28 upon 28 plus 4 plus 48. This is equal to 28 upon 80. And when we multiply 28 upon 80 into 100, we end up with a 35% by mass of nitrogen. So this makes option D the correct option for this question. Question 24. A student makes three suggestions about the Haber process and the contact process. Only one process uses a raw material obtained by fractional distillation of air. So fractional distillation of air produces nitrogen. So Haber process uses nitrogen. So this is correct. Only one process involves the use of a catalyst. No, Haber's process has iron or iron oxide and contact process has vanadium 5 oxide. So this is wrong. The product of each catalyzed reaction has a formula of the type XY3. So for Haber process, it is NH3 and for the contact process, it is SO3. So XY3 is the correct type of formula. Therefore, if only statements 1 and 3 are correct, this makes option B the correct option for this question. Question 25. Which uses of sulfuric acid are correct? As a bleach in the manufacture of wood pulp for paper? No. Chlorine is used in bleaching wood pulp. As food preservative in tinned foods, that is the role of SO2. As a raw material in the manufacture of detergents, this is where sulfuric acid comes in. As a fertilizer, fertilizers are ammonium salts. Sulfuric acid is involved in the formation of ammonium sulfate, and ammonium sulfate will be used as a fertilizer, not sulfuric acid directly. So, since statement 3 is the only correct statement here, this makes option D the correct option for this question. Question 26. Element X forms a covalent compound H2X in which X will have a 2 negative charge. An ionic compound Na2X, again X having a 2 negative charge. However, in the covalent compound, the 2 negative charge is its oxidation state, whereas the 2 negative charge in the ionic compound is the oxidation state as well as the ionic charge. And it forms oxides XO2 and XO3. So, in order for an element to have a 2 negative charge, it should belong to group 6. And since we have oxides forming, so this should be sulfur, SO2 and SO3. So that makes it H2S and Na2S. Hydrogen sulfide, sodium sulfide, sulfur dioxide, sulfur trioxide. And what are they asking us? To which group of the periodic table does X belong to? Which means to which group of the periodic table does sulfur belong to? It belongs to group 6, making option D the correct option for this question. Question 27. Which property is common to calcium, potassium, and sodium? Their atoms all have more neutrons than protons. So, calcium has a proton number of 20, potassium has 19, and sodium has 11. So, the statement says the atoms all have more neutrons than protons. So, for calcium, 40 minus 20 gives us 20, which is equal to the number of neutrons. So calcium itself makes this option incorrect. Their ions all have 8 electrons in their outer shell. So Ca2 positive ion will have 8 electrons in the second shell, in the third shell. K positive ion will have 8 electrons in the third shell, and Na positive ion will have 8 electrons in the second shell. So their ions all have 8 electrons in the outer shell? Yes, because in each case the outermost shell gets all its electrons removed and the inner shell has all its electrons present. They all sink when added to water. Potassium and sodium float on water. They are all deposited at the positive electrode when their molten chloride is electrolyzed. Now, positive electrode is referred to as anode. Anode is where oxidation takes place. Any metal ion will accept electrons to form the metal. So, they will undergo reduction. That means this is not going to take place when the molten chloride is electrolyzed at the anode. It's going to take place at the cathode. So, this makes option B the correct option for this question. Question 28. Palladium is an element, atomic number 46. Some of its properties and the properties of its compounds can be predicted from its position in the periodic table. Okay, so palladium is found in the D block of the periodic table, making it a transition element. Okay, so now predicted properties of palladium. Its density is similar to the density of sodium. Cannot be. Transition elements have a higher density. Its density same reason. This is wrong. It is present in compounds in more than one oxidation state. Yes, that is what transition elements are known for, having variable oxidation states. So options A and B have been eliminated. Options C and D will be carried forward. So now, predicted property of palladium compounds. Some of them can act as catalysts. Yes, this is another property of transition elements. The elements of the compounds can act as catalysts. And they are white in the solid state. No, transition elements form colored compounds. So option C is correct. Option D is incorrect. This makes option C the correct option for this question. Question 29. Three different elements react by losing electrons. The ions formed all have the electronic configuration of 2,8, which means there are 8 electrons in its second shell. So the electrons that were lost from the third shell, meaning they belong to period 3. So which statement about these elements is correct? They are in the same group? No. They are in the same period? Yes. Period 3. They are noble gases? No, then they will not be reacting. They are transition elements? No. So this makes option B the correct option for this question. Question 30. A power cable requires an element that conducts electricity. Power cable, yes. Has a relative low density? Yes. Is resistant to aerial oxidation? Of course. And all these properties are present in the element aluminum, and that is why it is used in power cables. Okay, so which of these conditions does aluminum okay, they mentioned aluminum. Which of these condition does aluminum satisfy? All three. So this makes option A the correct option for this question.